Thank you for inviting me to share the work that BDS has been doing with ISNIs. Get my slides up first of all. Oh, right, okay. I'll explain a bit about what BDS does overall and how ISNI is being used by us at the moment and what we're developing for our own workflow initially. And then, of course, answer any questions in due course. So, BDS is a cataloguing agency in the UK. We not only create bibliographic records for published resources, we create records in advance of publication. This supports acquisitions and shelf-ready services within the library sector, but it also contributes data to the British Library CIP programme. As this infographic shows, we also manage data for film and music as well as books and have customers in trade as well as library sectors. I'm going to focus on the book division side of things, which is much more focused on library standards. And I just want to explain a little bit about how we organise our workflow, because the ways in which I want to talk about how we're using ISNI very much pertain to our workflow. So we receive nearly 500 separate Onyx feeds from approximately 15,000 publishers. And that incoming data in Onyx, we map to Mark 21 and import to our bibliographic records database so that when we are actually doing the cataloguing work, we don't have to retype everything. What we're doing is applying the RDA guidelines to standardise and verify all the data points. And in addition, we assign DUI, LCC, LCSH, although we'll be switching to FAST fairly soon for linked data reasons. The Mark 21 records are then exported when they're complete to our customers according to their needs. And the small team of highly skilled cataloguers, which is supported by our in-house IT system, created over 198,000 CIP records and 35,000 confirmed records in 2021, despite lockdowns and changes and working from home and all the rest of it. So one of the significant tasks BDS cataloguers have always done is select the correct name heading from the NACO file. You may know that as the LC names file. We have it integrated into our in-house data editing software, and on export to customers, these name headings show in the bibliographic record as the standardised text string. But for over a decade now, we've been trapping and storing the NACO control number. This is an LC authority record just highlighting the text string and the name authority, the control number, and then our record showing that control number trapped. And what that allows us to do is ensure that whenever we export that MARC record to a customer, it always has the most up-to-date version of the text string, because we pull that in on the basis of the control number every time the record is exported. So we don't have to do additional maintenance work on the bibliographic records. So for all the reasons everyone else here is interested in ISNI, we started to look at this additional identifier. NACO headings are still going to be important to us because it gives us that prescribed text string for library catalogue records. But the ISNI brings us in these other beneficial qualities, not least the fact that it's linkable and can do this bridge identifier across multiple domains for us. And because standard identifiers support these exchange of data, workflow efficiency and e-commerce and so on, publishers are also getting interested in it. So BDS wanted to do this, interested in it, great. But as Vincent so clearly illustrated, we can't keep on increasing workloads and expect to maintain productivity and everything else. So we sought a way of doing this that didn't actually require a manual interrogation of the ISNI database and logging of the ISNI control number. And the first solution we put in place was with the help of the British Library. They provided us with a matching file. So it pairs NACO control numbers, which we already have, with ISNIs. BDS programmers put together a process that looked at our bibliographic record, took the NACO ID, found the corresponding ISNI, and then were able to post that ISNI into the MARC record being exported to the British Library. There are over 6.3 million pairs in the matching file. So at the moment, if we have NACO and we have a hit in the match file, then we can supply the ISNI in the exported mark. However, those two conditions, not surprisingly, will not always be met. And what we figured that we wanted to do was basically use the sort of positive feedback loop of linked data principles to develop a solution. We signed up to be an ISNI registration agency to enable us to work better with the ISNI database, and have started developing an internal names table. So we take the sort of idea of the matching file and then boost it in various ways. So in the major factor in this is the volume of data that we receive from publishers. The contributor block in ONIX has a long list of potential identifiers that they can use. This is a small selection of the codes that can be found. Publishers are interested in ISNI for their own authority control and are starting to include it in their processes. But even if they're only using their own proprietary identifier, it's still useful to us to trap that data, because we can then use that to build on other knowledge we're gaining elsewhere in our database. The initial work that we've done on this, we've got over 800,000 entries in our internal table. And of those, just over 7.5% include an ISNI, less than 1/3% have an ORCID, and the vast majority, over 92%, have their proprietary ID from the publisher. But the idea is that as soon as we trap that bit of information in the ONIX, and then we're doing our own work in the cataloguing team, we're adding NACOs, which can then, with the matching file, add ISNI, and we can gradually, with this, as I say, positive feedback loop, build things up so that we can get the benefit of this trapped knowledge. So the benefit to BDS of creating and maintaining this table is that it adds yet another bit of streamlining to our workflow. When we first started in 1995, work was pushed through the operational workflow with a piece of paper. So publishers would send us information, and often at that stage it was a printed catalogue of their planned publication output, and we would take those bits of paper through the building and get the various bits of work done, the name authority, added the DUI, so on and so forth. And we had piles of paper on a desk at the start of the procedure, organised by publication date and priority and so on, and staff physically helped themselves to batches of work. Initially, everything had to be typed in, and then ONIX feeds started to be imported, and that reduced the scratch work that we had to do. And then we created what we call AWA, Automatic Allocation of Work, and that replaces this physical bit of paper with a digital setup which pushes work through the workflow. So you can see there's a group of 2 ISBNs records. They have the same title. It's the print format and the digital format of the book. So obviously we don't want to split those up in the workflow. It's much more efficient to deal with the subject indexing and so on at the same time. And we create the 2 ISBN records, and I click the green tick at the bottom to say, yeah, done, give me my next bit of work. We also have the icon at the top there is perhaps too small to see, but if you click that little clipboard image, you get effectively the piece of paper in digital format of what the publisher's information is, so that the subject indexing work and so on can be done on that basis. So what we'll be able to do, when we call up an ISBN in our system, the record is populated, as I say, initially by any data we have from the ONIX feed, and cataloguers then verify, standardise and add in the other pieces of information. What we are going to be able to do with our names table is that we could have the NACO heading already pulled in, because we've trapped that information. We know what the proprietary ID from the publisher means in terms of a NACO ID, so we can pre-populate the incoming beginner MART record with the correct heading if we have the data to base that on. If we don't have the data to base it on, we may have by the end of the cataloguing process. So the cataloguer assigns the NACO ID, and that can be fed back in so that we're constantly adding to the knowledge that we have trapped. And over time, this will hopefully build up knowledge, which of course just leaves us with how do we plug any gaps in our knowledge of an agent's ISNI. The names table means we're going to get closer to having an ISNI for every name heading in our BIP records, but there will inevitably be gaps, which means we're back at the how do we automate this question. Hopefully this decision tree shows that whilst there will still be a requirement for some human verification, it is made as efficient as possible. So we've really only got one step in this process where we really need eyes on to properly make sure we're disambiguating and choosing the correct thing. The searching of the ISNI API, and in time will progress as a registration agency to the assignment of new ISNIs, can be automated again through the use of data we have from our Onyx feeds and our BIB data. We shouldn't need to be doing manual data input because we've already trapped the critical information in terms of the name string and the date of birth and which works they're associated with. So I hope this illustrates well that the automation of tasks can be supported by using identifiers such as ISNI, and we're going to be using it to support our productivity as well as improving interoperability with bibliographic data now and in the future. There is no substitute for a human cataloguer when it comes to disambiguation of agents' identities. Whether you're trying to distinguish between the Dumfriesshire-born father of the US Navy, John Paul Jones, or the Led Zeppelin bassist, John Paul Jones, once that decision has been made, we want to use that and not have to make that decision again. So we'll keep going with our positive feedback loop. I hope that's all clear. I'll be here for questions later. Thank you.